Hey everyone, today I'll be introducing WebHacker, our new open source tool for reverse engineering web apps and turning complex browser operations into APIs and MCP tools for AI agents. To get started, clone the repo in the description. You will want to make sure that you have Python 3.11 or higher, Google Chrome installed, UV Python Package Manager, and an OpenAI API key. Follow the instructions in this section. My environment's already set up, so I will skip this for now. You will then want to launch Chrome in debug mode, which will essentially allow us to programmatically interact with it. We'll paste these commands here, and you should see a new Chrome context pop up. We can go ahead and close that. To make sure that we're able to programmatically interact with it, we can paste this command here, and everything is working perfectly. As we can see, we have a address with which to communicate with this instance of the Chrome application. WebHacker itself works in 3 stages. The first is monitoring a Chrome workflow that you'll be performing. In the second stage, we run our AI agent on the data collected from the debug Chrome mode to uncover any APIs. And in the third, you will be testing and executing the APIs uncovered by the agent. To get started with the first stage, we can paste this command here. This will launch a new Chrome tab where we'll be performing some task. In my case, I want the API for Spirit Airlines one-way flights. So we'll go ahead and open up the page. We can go ahead and stop this monitoring session. This new directory was generated here, CDP captures, and here we have consolidated transactions that contain the requests and the responses, and also we have all of these transactions that include the response bodies. Additionally, we also have the storage related information, which means changes in cookies, session storage, and local storage for extra context. We can now move on to the second stage of our pipeline, which is running the agent on all of this data. The agent will uncover the APIs and the structure of the web application. So here we can copy this command. And of course, we have to update the task. In our case, it is searching for one-way flights and their prices. And we'll go ahead and run that agent. This can take a few minutes. After our agent runs, we'll get this directory routine discovery output with 2 key files, routine.json and test parameters. In the routine file, we can see the agent has chosen to take some operations. The first one is navigate to Spirit, then we sleep for 2.5 seconds. We can see that the first fetch that the agent performed was actually a request to get a authentication token. And here the agent decided to put that into a session storage key called token responses. In the second fetch here, we are actually hitting up the Spirit. Here in the authorization, we can see the token we uncovered with a previous fetch request and placed into token response. This is a placeholder which will be resolved at runtime dynamically. Here we also have some placeholders for user inputs, in our case, the origin, destination, and the date. We can also see the last token here. The last user input is the number of passengers, and all of the user inputs are summarized in this parameters section. Let's now take a look at the test parameters. Let's go ahead and execute this routine with the test parameters. As you can see, you can copy this command. It's launched the browser, performed the operations, and gave us the final output.